Hello, in this video we'll discuss section 17.1, the sampling distribution of a proportion. We're going to be working with a categorical variable, and as you recall, categorical variables record a group designation such as gender. A little bit later we'll work with quantitative variables, which measure a numerical characteristic such as height. In a face-to-face setting, I normally do an activity where each student takes a random sample of 25 Reese's Pieces candies. I then have you determine the proportion of orange candies in your sample. Now, those of you that are a fan of Reese's Pieces candies, you know that color is a categorical variable. The Reese's Pieces candies come in three colors: orange, brown, and yellow. And I often ask, after you've taken your sample of 25 candies and computed the proportion of orange candies, does that proportion match the proportion that your neighbor found? And of course, most of the time the answer is no. This illustrates a phenomenon known as sampling variability. Values of sample statistics vary from sample to sample. Now, we should distinguish here between distribution of the sample and sampling distribution. So let's just suppose we take a sample. In the class activity, you would take a sample of 25 Reese's Pieces candies. If you look at the distribution of the values for a particular sample, this is the distribution of the sample. And you could create some sort of graphical display where you have the different categories, orange, brown, and yellow, and you record the counts for each of those categories. This is in contrast to the sampling distribution, where you imagine taking every possible sample of 25 Reese's Pieces candies and then looking at the sample proportion for each of those imaginary samples. Let's use an applet to simulate drawing many samples. Now, if you think about all the Reese's Pieces candies manufactured by Hershey, we may not know the true population proportion of candies that are orange. In fact, that's why we're drawing a sample. We want to use the sample proportion to help us estimate the true population proportion of orange candies. So for purposes of this simulation, we're going to have to suppose we do know the true population proportion. Let's just say it's 0.45. So I want to draw a sample of size 25. I'll click the Draw Sample button, and the candy machine is spinning away, drawing our sample. And notice the sample proportion of orange candies is 0.44. So let's do this a few more times. I'll have it draw 4 more samples, and I'll uncheck the Animate box here. So now we have a total of 5 samples, and you can see the 5 sample proportions plotted here. So we're going to see that even though the sample proportion varies from sample to sample, there is a long-term predictable pattern to this variation. To help us see that, let's draw many more samples. I'll add 495, so we get a total of 500 samples, and here you go. This is the display of the sample proportions for these 500 samples. And what you notice is this distribution is roughly centered at 0.45, the true population proportion. It appears to be roughly symmetric, and we could determine the spread from this as well. Let me check the plot normal curve box here, and there you have the plot. It appears to fit the distribution fairly well. Now let's investigate what happens if we change the sample size. So instead of a sample of 25, let's do a sample of 75. I'll reset this and we'll do a total of 500 samples. And notice what we have. We have the display of the sample proportions. It's centered roughly at 0.45, roughly symmetric looking, but notice here we have less spread than before with the smaller sample size. Let's stick with a sample of size 75, but now suppose the true population proportion of orange candies is 0.25. How do you think that changes things? Well, we'll draw 500 samples. And now we see the distribution is centered roughly at 0.25, the true population proportion. It's roughly symmetric and looks something like this. So this is our first look at the sampling distribution. I'll have more to say in the next video. See you then.